Alright, so here we're going to look into 5.4, graphing square root functions. Here's the why. Square root functions offer us insights into quadratic functions as their inverse. This is particularly useful for projectile motion or gravity. Square root functions. They are going to be the inverse of x squared. Right, so if we talk about some graphs here, x squared, which we did in chapter 3, looks like that. If we talk about its inverse, which would be reflected across the line y is equal to x, would then be that sideways quadratic. Now, when we're graphing them, what we're going to notice is that we only talk about this top arm. And the reason we only talk about the top arm is because this is the positive case, this is the negative case from the old plus minus scenario. But I can't have them both because then it doesn't pass the vertical line test and it's no longer a function. So we're going to be focusing on the positive case only, which is why here in this picture you only see 1/2 of the sideways quadratic. These are going to use the exact same shifts that you guys are familiar with back from chapter 2, to where the k value, that moves you up or down. So it's a vertical shift. The h value is left and right, horizontal, but as you guys remember, due to that negative sign, it's always going to be the opposite of what you expect. The a value covers the stretch or decay. Stretch or compression. Depending on if it's bigger than 1, right? If a was bigger than 1, it grows faster than normal, so it's a stretch. For compression, if a is less than 1 but still bigger than 0, it was a compression. And then also, if there's a negative there, that's where you flip over the x-axis. It's called a reflection. I encourage you to think back to how we used these in chapter 2 because they're the exact same concepts that we'll use today. All right. Now, the domain and range for square root functions is going to take a little bit of thinking and work. Now, remember that domain is all possible x values. But we can see here on the graph, like on this graph, or the most generic square root graph, it's going to look like this. The domain is not all real numbers because I don't go over here. I don't go that far left. I stop right there. So that starting point is going to impact both the domain and the range. The way to find the domain is to figure out what makes these stop. Now, square root functions are good to go. I can square root a 0, I can square root a positive number, but if we try to square root a negative number, we get an error. And yes, we could talk about imaginary from last chapter, but that's not going to be prevalent here in this chapter. So to find the domain, we're going to need to take this scenario here and talk about what's going on. Our inequality is going to be the stuff underneath the square root, x minus 3, has to be equal to 0 or bigger. Right? So this inequality is saying that this side on the left is going to have to be 0 or bigger. It had to be one of those two cases because I set it up that way. X minus 3, which is the stuff underneath the square root, must be 0 or bigger. And then when we solve, by adding 3 onto both sides, we'll get that the domain must be x is greater than or equal to 3. All right. Now, to find the range, all you'll do is you'll go to your function and you'll plug in the same value that you got for your domain. So when I do that, we'll get the square root of 3 minus 3, which is the square root of 0. Square root of 0 is 0. So our range is going to be y is greater than or equal to 0. Now, a lot of people have a tough time with domain and range until we look at it graphically. Let's come down here to number 1 and make the very most basic square root function, the square root of x. And then we're going to come back and talk about this problem that we just did. Alright, let's actually make a table for this one. And you could type this into your calculator, but we can make a table no problem. 0, 0, because if I plug in the square root of 0, it's the answer of 0. I can take the square root of 1, because the square root of 1 is 1. The next x number I pick, though, needs to be 4, because that's the next number that I'm easily able to square root, which would be 4. And when I square root it, I get a 2. Now, the next one would, in fact, be 9 to get the answer of 3, but that one's not going to fit on the graph. So there's the most basic table. There's the most basic graph. Its domain starts at 0, right? Because you track how far left can we go. Furthest left we can go is 0. So x is greater than or equal to 0, because I can now go to the right as far as I want. For the range, how far down do we go? Well, 0, because we start there at 0, 0. So y is going to be greater than or equal to 0. So this right here is the generic domain and range. X is greater than or equal to 0, and y is greater than or equal to 0. Basically saying we'll go anywhere in this first quadrant, so anywhere in this first quadrant that we want. That's where this graph will live, only in that quadrant. Now, what you'll come to find out is that h and k values impact the domain and range. And we're going to see that on 1, 2, and 3 right there. This one here had an h value of 3. All right, you might be thinking, Mr. Cottle, but it's a negative 3. Nope. Remember, it's always the opposite of what you think. So the domain will actually become whatever that h value is. And it's actually going to work the same way for the range. The range is going to become whatever the k value is. We don't have a k value on this one, so that's why the range remained unchanged. The way that's going to impact us here, though, is that we could now quickly identify what the domain and range is. All right, because they'll start off like this. As far as the domain goes, it's going to be the opposite of the number on the inside. And that's because what this graph would look like is a shift to the left 2. This graph would look like this. That positive 2 is the opposite of what you'd think. It would shift us to the left 2, moving my starting x value here to negative 2. But without there being a k value right here, notice I don't move up or down anywhere. So my range will still be y is greater than or equal to 0. Let's try this one. So we'll talk about domain and range. A values don't impact domain and range. They change how fast it grows, but not where it starts. The domain is always your h value, is opposite of what you'd expect. So this one would be 4, and then my k value on this one is 2. And what this would look like from a graphing perspective is that this one would move right 4 and up 2. And that's where it would start. So that's what changes our domain and range, are those h and k values. Number 3 is a little tricky. To determine the domain, you'd actually need to do the inequality concept again, where you have everything underneath the square root must be greater than or equal to 0. So then when I subtract by 7 and divide by 2, we'll get that our domain is x is greater than or equal to negative 7 over 2. That's where that one would start. And you might be wondering, Mr. Cottle, what about, I thought you said it would be the opposite of this h value. That is true. We won't spend very much time at all discussing what this guy does, a number with the x. It does end up changing your h value. So I wouldn't give you one where you have a 2 like that on the test, but I did want you to see one here for us. All right, now the range on this one's also going to be different because of this negative sign. We know that these graphs typically start at 0 and open up. That negative sign, though, is going to flip us down. So it's still going to be y and 0, because I still have a cutoff spot here at 0, but now notice that my y values are less than or equal to 0. So that's what that negative sign will end up changing. He ends up flipping that inequality. And that example is more complicated than we need at this point. I just wanted to go ahead and showcase you that so that you could be prepared for ACT questions or anything like that. But we'll more so stick with these guys where the domain and range is directly impacted by the h and k values. When it comes time to make graphs, which we'll explore more in the second part of the video, we are free to use our calculators, especially when we have this value here, a number with the x. They didn't even address it in the chart up here. They didn't talk about what a number with x does. It does do something that creates a pattern, but it's quite complicated. We're going to just type this in. We can find our domain, though. Domain would come from taking what's inside the square root and setting it up equal to 0, adding 2 onto both sides, and dividing by 3. So our domain is going to be that x is greater than or equal to 2/3. All right, and you can see that right here. This graph starts at 2/3, which is almost to 1. And the range is greater than or equal to 0 because I had no k values. The way that you should take care of this by graphing is type it into your calculator. So if you go to y equals and you type in the square root of 3x minus 2, and then you hit second graph, it'll take you to the table. So go ahead and take an opportunity to do that. Go into your calculator, push your y equals button, type in square root of 3x, subtract 2, not negative sign. Second graph will give you a table, and you can start to plot some of the points. We know that the first point is 2/3, 0, and that's why it's important to calculate that, is so that we know where it starts. Because we can see it's not a whole number, but we know what that whole number is. It's 2/3. And then looking at the table in your calculator, you'll see another point is 1, 1, which is right there. You'll see another point is 2, 2, which is right there. And then you get a bunch of decimals until you get to 6, 4, which is right there. So we'll certainly have the calculators to assist us in graphing square roots. We'll talk about some shifts as well, but the main way that we'll take these down ultimately, especially if you're confused, is typing them in on your graphing calculator and going to second table.